Hello everyone, I am Senapati, Assistant Professor of Civil Engineering at Vedang Institute of Technology. So, as we discussed about strength of material, so in our module 1, we have already completed principal stress strain and that are like compound stresses, simple stresses, all those things. So, in this class, we will start module 2 and we will discuss about shear force and bending moment. So, first, what is shear force? So, first to know shear force, we need to know about what is normal force and the difference between normal force and shear force. Okay. So, you can say let us just differentiate it and let us this side shear force and here let us take normal force. Okay. So, what will be the big difference between normal force and shear force? To know, let us take an object at both the sides. Okay. So, when normal force applied on any object, we know the normal force will be applied perpendicular to the object. Okay, perpendicular to any particular axis. You can say here this is applied on y axis, here in x axis, but in case of normal force it is always applied perpendicular to the object. So, first point is the force is perpendicular. Force is perpendicular to the object. Okay. But in case of shear force, you can see always the force will be parallel to the object. You can see the force will be parallel to the section. When the force is if only in this direction, what happens? The object will be what? If it is in case of normal force, there will be two types of forces. One is tensile force and another one is compressive force. Okay. So, here all the forces applied are what? Compressive in nature. But if we just apply force like this, okay, we can see it will extend. Okay, it will what? Pull it. Okay, but in case of shear force, what happens? This object will, if the object is fixed at some point and the force acting like this, so object will break at the center. Okay. So, this is the big difference between shear force and normal force. But you can say also the shear force is nothing but what? Resultant of all the forces okay. How it is the resultant of all the forces? Like in case of any particular beam, let's if we have a particular beam, okay, if we have the beam and we can see there is one point load, let us take it as A, and another one is UDL. Okay. So, shear force will be the resultant of this UDL and point load. Okay. So, there will be no difference if we add the point load A and let us take it B. So, the shear force will be nothing but this calculation of point load, let us take it as P. Okay. At certain side, if we will take the left one side or you can take the right side. Okay. To calculate this, we will take one side for this side or you can take for this side. Okay. So, if we calculate this point load P in left side, so here our resultant forces will be, we will calculate in future, but we need to know that the addition of forces will be our shear force. Okay. Next, what? We need to know what is bending moment. Okay. So, to know bending moment, to know what is bending moment. Bending moment is nothing but the effectiveness of shear forces or any type of forces. After application of force in case of any body, what is the effect that we will calculate in case of bending moment. Let's take an example. Okay. If it is the body and we have supported it here in cantilever. Okay, we have taken one what? Cantilever beam, and now we will check how to calculate bending moment and all. So, it is the length of the beam is D. Okay. So, if we just put one force here, take it F. So, what will happen? We know the support is fixed here. One support is fixed. So, it will bend like this, right? It will bend like this. The beam will bend like this. So, the effect of the force, due to the effect of the force, the beam bends. You can write it, okay? But due to the effect of force, the beam bends downward. Right? Due to the effect of force, this beam bends downward. So, to calculate the bending moment here, we just need to put the formula moment is equal, or you can write direct Bm, and due to shear force you can take SF. Normally you can take SF and Bm. So, Bm will be what? D into F, or you can write F into D. The force into distance will be your bending moment, and by using this formula we can find out how much the beam bends. So, you can notice here we have term one beam, that is cantilever beam. Okay. So, there is a lots of types of beam in our next class. We will discuss what are the types of beam, how to, like, here we have taken the downward direction. So, for downward direction, what sign we will use, and for other things what sign we will use. So, in our next classes we will discuss the sign conversion things. So, in this class we just discuss about some basic things, that is what is shear force and bending moment. In our next class we will discuss the types of beam, types of load. Also, you have noticed here we have used one point load and UDL. I have already told that UDL. Okay. So in next class we will discuss types of beam, types of load and all those things. Thank you so much.